Okay. So yeah, last class we saw the Wi-Fi. So this class will try to understand the hash cracking. Say hash cracking. So we'll try to understand what is hash, how to crack it, where it's used, and everything. So so first we should understand what is hash. Like, what is a hash? So hash is basically like a you can think like a one-way ticket or one-way encoded string or one-way uh, let's say one-way message. Let's say example. Let's say I give a simple message. Example, hi. The hash would look something like this. Example. Sorry. Something like that. Random. So this is an hash. So the reason why I call one-way means you cannot take hash, you cannot convert it back to I. It's impossible. When if you know the hash, you cannot get the original message back. So that's maybe a good point. Original message, let's say I, cannot be retrieved by hash. You can. You can give a message, you can convert into hash, that's okay. But it's impossible to get the reverse. So that's why I call one-way kind of thing. So there are some properties. Maybe I'll just add some properties. Properties of a good hash. So one we call like deterministic. Again, these are very technical things, which means same input gives same hash. So this is what we call deterministic, which means if you give one input, you always get the same hash. For example, I give I, that's I'll get as like example 1, 2, 3, 4, 5, 6, 7, 8. Example. That's not the real hash, but the next time when I give hi or anybody gives hi, I'll get the same hash. It's not different hash because message is same, hash is also same. That's the first property, let's say. The second property, of course, irreversible. Irreversible. So which means we already talked like you cannot get back the message. You cannot get the original message back. That's the second property. And third property we call something called, I think, uh, let's say collision resistant, they call something like collision means like a conflict. Like, for example, if two inputs or two messages, example, produce same ad, if that's not a good thing. If two messages produce same hash, then it's not a good thing. So that means there is a collision, like both collide. For example, if I say hi, I'll get 1, 2, 3, 4, 5, 6 example like this. If I give hello also, let's say I get the same hash, then it's not a good thing because you don't know which message hash is what. So this is what we call collision. So hash means collision resistance, which means two messages should not produce same hash, should be different, not same. So this should not happen. So that's the maybe the last property I can tell you something like they call avalanche effect. Again, these are technical definitions of avalanche effect, which means a tiny change in message changes the hash completely. Example, simple. Let's say I give I, I'll get 1, 2, 3, 4, 5, 6. Now, if I do capital I should get something like you can see a small change. It's not a big change. It's very small. Instead of small letter, I put capital letter. The hash should be completely different. Even simple thing, dot, space, whatever you make tiny change, the hash will be completely different. It can be like same hash. So that's it. Yeah, that's it. This is what hash means. These four properties. One is deterministic, same input, same hash. Reversible, you cannot get the original message back. Collision resistant, which means two inputs cannot produce same hash. And the last one is a tiny change in the message can change the hash completely. So let's go to our hacking platform and see. Let's go to hack.degenden.xyz. So there is a lab here, hash cracking. Let's try. You can see so there are a bunch of algorithms to generate the hash. So these are different algorithms, but properties are same. Hash properties are same. This is older, very fast, but older, like we don't use. This is okay, but still. So this is the current one, which is used very popular frameworks and stuff. So this is a little bit advanced. So yeah, mostly this is average, you would say, normally people use, but these are all advanced hashing algorithms. So let's try simple one. Let's try give test. You can see I get this hash. So this is the hash looks like using this algorithm. Now, if I make a tiny change, for example, let's try all these properties. First property is what? Deterministic. So remember this hash. I'll copy, I'll paste. Next time, I'll just give the same message or reload example. I'll give the same message, test, generate. You can see same. Same input always produces same hash. That's the first property. That's done. And the second thing, of course, you cannot get the original message back from this. It's very hard to get the original message back. Third point is collision resistant. We cannot test this, but we assume that there is no other message that can produce the same hash. And the last one is avalanche effect. We can change this. So let's say I'll just simply add a space. You can see this is completely different than this because tiny changes. I just added some space. That's it. If I go back again, I'll get the same hash. So those are the main idea of hash. Hash means that only. If you have these properties, you can consider that is a good hashing technique. Mostly used for passwords, actually. Passwords. So let's say we have our account, right? Platform account. In our account, you log in with the password. Your password is basically stored as an hash. So let's say if we give password test, so it will store this hash. Example. So we don't really store the passwords in database like thing. We store their hashes like typically most common. Yeah, that's the idea of hashing means. Like any question up to this point, online, offline. We can try another algorithm also. Let's try this algorithm. You can generate. So this has different thing. Maybe I forgot to tell you. Hash always produce same length of the hash. Whatever message you give, the length of the hash is same. The length, like number of bits. You can give the entire document, you will get the hash like this one, like lengthwise. Of course, value is different. You can give a song, you will get an hash. You can give a message, you will get an hash. So that's a fixed length or same length. Fixed, let's call it fixed length. The length depends on the algorithm to algorithm. Let's say SHA-256 has a different length than the MD5. Then SHA-1, let's say. You can see this is a different length. This is a different length. This is a different length. The message is same, but hash is length is different. Of course, hash is also different. Yeah, that point I think you should remember. It has a fixed length. Depends on the algorithm. Whatever algorithm you use, length is fixed. Hash will change. No matter how big data you give, you still get the same number of length. Hash is different, of course. Yes. Any question? Anything up to this point? I mean, so far we're trying to understand what hashing means. We're not going to attacking it, but we're just understanding what is hash. So any question up to this point? Different hash. Yeah, so now let's try to put an attacker at. Let's say, since we know what hashing means, we already know the application also. Application is mostly passwords are stored in hash. Example, somebody gives you an hash, something like this, doesn't matter. And your job is to crack it. Crack means get the original message back. So now how do you think like it? Right. So as an attacker now, somebody gives you an hash. Now your job is to get the original message. Goal is to get the original message. That's a password in this context. Now, how do you go about it? Like, since we know that, hey, you cannot get this from original message. That feature is there. That property is there. Hey, you cannot decode this. You cannot do anything to get the original message. But still, you want to crack it. So think like that. How it happens. So let me give you some simple example. So I'll say hash is typically calculated something like this. So you give input message, let's say. The input message goes to some hashing algorithm. I'll call algorithm. The algorithm will produce the hash. This is how it works typically. Let's say, for example, I give a pass test as the input. The algorithm will take that. It will produce this hash. Okay. So that is the flow. That is how hash is calculated. Now, the first step you need to understand is, as an attacker, you try to understand what type of algorithm they might use for this hash. So we already know some information like hashing as fixed length. It depends on the algorithm. So based on this length, you can try to guess it at least. Hey, is this a SHA-1 algorithm or SHA-256 or MD5 or something like that? So typically you will get to know that. That's easy. So that you can first use that only, like hashing algorithm, figuring out. That is little easier. You can, by looking at the hash, you can tell. Or you can go ask on internet, you will get it for sure. So you will find hashing algorithm easily. The next thing is what you do is, there is a idea called brute force attacking. Brute force means you try every possible combination. Try every possible combination. Example, I will try with A to Z. Example. And I try A to Z, Z. And I try A to example. Z, Z, Z. A to Z, Z, Z. Even numbers also I can include, but just talk about only letters. A to Z, Z. You can think like based on the length, it gets even more complex. So what I mean by that is, I'll do something like this. Let's say if I'm given this hash to solve, crack, I try everything. First, I'll give A, or let's say simple thing, A. I'll send it to the algorithm. The algorithm gives me hash. Let's say hash 1. Now I'll check if hash 1 is same as my original hash. the given hash. Example, simple comparison. So I just give an input to hashing algorithm. The hashing algorithm will produce some hash. I'll just compare it. Is it the same or not same? Okay, if it's not same, then move on to another A, B. Again, I'll go. Again, hash 2. Again, check. Same. Hash 2, check. Is this same or not? Okay, if it is same, then you cracked it. If it is not same, you try another. So this is how you can try all the way until you find the hash. But as you know that it's very expensive, like time and computational expensive, because you have to try every possible thing. You have to send it to algorithm, get the hash, and compare it. Like, but eventually, if you have enough computing power, you will solve it because you try all combinations. So imagine that for like OTP example, let's say OTP or phone lock. Phone lock, how many digits? Like 4 digits mostly. It's a 00029999. That's it. One of them is the true, right? One of them unlocks the door. So you can try all locks. 00 try, 001 you try, 002 you try, all the way to 1000 try, then 1001, 1002, all the way to 999. But you know pretty sure that one of them will definitely open the lock. But trying all these are definitely computational expensive. But since you only have 4, that's fine. But what if your password has like 00002 all the way to 9999? Now, these many combinations you have to try. That's like very expensive. But you will eventually find the answer if you have enough computing power, mostly hardware. So that's one attack, brute force attack they call. Try every single possible combination, see if it works. That's one. Is any question on the brute force attack online? Any question on brute force? Then there is another attack we call dictionary attack. So dictionary attack means dictionary means dictionary, right? A bunch all words, possible words. So dictionary means a popular, most popular or most, like, let's say not most popular, but I would say most popular passwords example stored in a file. So there is a famous file called rawq.txt. So let's say you can Google it. Let's say rawq.txt. So this file contains, I just downloaded it. Okay, it's getting downloaded. So dictionary attack means you store all popular passwords on the most popular or most common, popular or common, whatever you call it, like you store in a file. Like this. So let's see this one, rawq.txt. Common password list, you can see. So there is a file called rawq.txt. It contains, I think, I don't remember exactly how many, 15 million or something. Around 14 million passwords are there. The most common passwords are there. So you can try every password in that file, see if it matches or not. Instead of trying all possible combination, why can't you try all most common passwords? Makes sense, right? So that's how you do. But there are many other files also. There is a crack station file, which is around 15 billion, I think. We'll see. Okay, you can see. You see rawq.txt. All possible common passwords are there. These are all generally common passwords mostly. Yeah, you see, I think there are 15 million or something. We can just find it out. But these are, you can see, all common passwords starting from A to B or A to Z. Sorry. Let's see list. Raw queue, txt, length. I think 15, 14 million, something like that. Let's see. 14 million, something like that. It has 14 million passwords. That 133 MB, something like that. Shortest password is A, the longest password up to 32 characters, something like that. So yeah, another attack is dictionary attack. You try all possible combination, all possible most common passwords. So that is either raw queue or there is another thing called crack station. It has roughly one file, maybe something like this. Yeah, something like this. So this contains it's a 15 GB file. You can see this contains, I think, 15 billion or something. Let's see. I can see these many passwords. I'll just ask directly. Nearly 1.5 billion passwords are. You can try all 1.5 billion passwords one by one, like see if it find any match or not. So that's another attack. So mostly dictionary attack, which means you have a bunch of passwords list. You try on each thing. That's one attack. So yeah, any question on the dictionary attack? So there are many files actually. I only showed you common these two, but you will find a lot more files if you Google it actually. But I have some link. Let me share that link. Yeah, there is a website, over the website, where I can see all the password, where I can see all different dictionaries, dictionaries of passwords. Over the website, it's a famous website only. You can see a lot more files actually. Weakpass.com is one. You can see this contains a bunch of dictionaries. So many files are there. 2 GB, 17 GB. Yeah, see, word list, right? So this is one of them. This is also good, right? Collection of password list. Yeah, you spend some time. Depends on, you can say raw queue 60 million passwords are 60 or something. Raw queue 65. Yeah, different passwords are there. So there's also like checklist is from I think it's that only .txt. Open wall word list is another. So this is also in different languages you will use. Yeah, so these are some of the top popular password is also one. Yeah, I think weak pass, open wall, checklist. I would recommend you to try in the beginning. Yeah, so that's the second attack, dictionary attack. The third attack we call rainbow table attack. So which is like you can think like a pre-computed hashes are stored. Example, hash one, text is hello. Hash two, example, I'm just making that. Hello, hi, hello. Hash three, bye. Example. So we call these pre-computed. So which means you have an hash and you have a corresponding message also. Like in a file, you will store both of them. You have the hash, you have the original message also. Again, this is also a file. You can have a number of hashes. Now, let's say you are given a task to find the original message from this hash. You will simply look up this hash here. Is it matching here? Is it matching here? Is it matching here? And so on. If anything matches, then you take that. It means it's already computed. You don't need to compute again. So these are stored in a file already. In dictionary, you have to compute it, which means you take one password from file, you run the algorithm, you get the hash, and compare that hash to your attacking hash. But here it's already computed. You just need to check it. Is it there or not there? This is also similar to word list. You have a list, you try it. Mostly these three things are common attacks. I see. So just to give you some idea, I just entered something like 1, 2, 3, 4. I'll just take SHA-256. Generate. Just to give you an idea, there is a small simulation. First, I'll create a small dictionary file. That's a rocky.txt. Let's create a simple test 1, 2, 3, 1, 2, 3, 4. Hello, hi. I'll save as rocky.txt. Just for fun only. Now in our simulation, I'll just upload the file. And let's start dictionary attack. I click. You can see it's matched 1, 2, 3, 4. Because in our dictionary, we have 1, 2, 3. If I give hello, already there. Hello. But if I give you something different, which is not there, no match. Because you don't have that dictionary. So that is like a simulation, but it's real. It's a small simulation, but it's completely real. You can have a big file of all these rocky.txt you can apply. I can apply also rocky.txt. Let me apply. But we have a limitation actually. But let's see. I'll just upload this. Desktop. Replace. So I'll just give it something like, I don't know, get the hash. I'll try to upload the big file. Yeah, I think the problem is, okay, it's starting. Yeah, so there is some limitations, like we cannot have, some limitations are there. Yeah, in our file, I just put some limitations, so I cannot add like more. But you can try a bunch of common. So this is just simulation just to get an idea. But in real life also, you do pretty much same. Yeah, so that's the idea of attacking hash, 3 ways. But now let's try to understand the tools to do that. So there are some common tools. One is like John the Ripper. It's a tool. It's a password cracker tool, John the Ripper. It's a library or tool, whatever you call it. All you have to do is like, it's a simple commands only you give. For example, I want to crack a hash. I want to crack and you will give like, first you install the library, whatever the OS, Ubuntu, Linux, Mac. Then you have your own hash, whatever hash you want to do. Then simply, this is this thing. You just run this command. You tell which algorithm is the hash. You provide the word list, which word list, and you provide the hash. So hash.txt contains this hash. By running this line, If the word list has matching the hash, it will find it. If the word list does not have any hash, then obviously it cannot find it. But this line will do all the poke. Uh, so instead of MD5, you can use SHA-256 also. Same idea, but you change the idea is same. John is the command. These are the options, like which algorithm you are using. So this is the input file, which input you want to take, like dictionary file. And these are the hashes, like direct hashes. Then once the result is done, you can simply see the result. You will contain the password or whatever hash. If it's found, if it's not found, then of course you cannot get it. Yeah, this is one John the Ripper. So there is but John the Ripper is mostly for CPU based. They call CPU based hash cracking tool. So there is also something called Hashcat. This is another library. It's a GPU based hash cracking. So as you know, CPU is very slow, GPU is very fast. So if you want to do serious hash cracking, you have to use GPU on. You cannot steal the passwords with this, crack the passwords with CPU, because CPU is always like less slow. But if you use GPU, it runs very fast. So if you want to try on GPU, you use this Hashcat library. If you want to try on CPU, you use John the Ripper. Since you all are beginners, so you try with John the Ripper only. But if you have hardware, you can try Hashcat. The commands also very much same only, maybe small differences. The syntax also very much same only. It's not that dissimilar. You will give something like this. You will give the maybe these are the some of the options you want. You give the word list. You give your hash list. That's it. By running this command on the Kali Linux or anywhere where Hashcat is installed, you will get the password. This is brute force mass attack, but again, this requires GPU. So you need to have the GPU physical hardware. Support CPU also, but GPU is the main strong GPU you need. On CPU only missions, John the Ripper usually better. You try first John the Ripper only. You try for basic passwords, and slowly you can improve your hash tracking. So hash tracking is a good technique. It's better to learn only, but you need to have a good computing power hours, like GPU or something. Maybe when we do Kali Linux, maybe next class onwards, we will try these. We'll try at least John Ripper. Hashcat will see if I can arrange some GPU. I'll try it. That's how you can think like attacking hash, cracking hash, like something like that. So hopefully you get some idea how to attack it. And next step is to do it. Maybe tomorrow we'll install Kali Linux. We'll install the John the Ripper. You try to prepare some passwords for yourself. We'll see if it works. We'll try all different word lists on these websites. Example, WeakPass. We'll try a bunch of, tomorrow we'll try all the word list. We'll see if we can crack password. Again, not all passwords can be cracked, because if I give a password, maybe something like, I don't know, like this, it's very hard to crack. Because nobody stores this as a dictionary value. So this is very strong password in it, I can say. If you give weak password, like for example, test123, it's a weak password. Let's say, or I don't know, like you give your date of births or phone numbers, all those are big passwords actually. So there is a website also, check if the password is already leaked or not. I forgot the name. You can check if the